Welcome students. So today we will solve some problems from relation and function, that is from our first topic, that is types of relation. But before that we need to recall some properties, that is reflexive property, symmetric property and transitive property. So here is reflexive property, that is A comma A. This ordered pair belongs to the relation for every A belongs to A is called reflexive property. Symmetric property is if A comma B belongs to the relation and it will imply B comma A also belongs to the relation, hence it's a symmetric property. And transitive property, A comma B ordered pair B comma C belongs to relation, and if it is implying that A comma C, this ordered pair also belongs to the relation, hence it's a transitive relation. So here is your first problem. So first problem is a relation is given and defined in a set A, and this relation is 3x minus y is equal to 0. That means y is equal to 3x. Now if x is 1, y is 3. Now you can check for each and every element, this x comma x does not belongs to the relation R. So first property, reflexive property, does not satisfy. Number 2, symmetric property. What is symmetric property? If y is equal to 3x, then x is 1/3 of y, which is not equal to 3y. Hence y comma x does not belong to the relation R. This number 2 property is not satisfying, hence it is not symmetric. Number 3, transitive property. If y is equal to 3x and z is equal to 3y, that means x comma y and y comma z belongs to the relation, that is z is equal to 9x, which is not equal to 3x, hence x comma z does not belong to this relation R, hence it is not transitive. Here is the solution. You can check this relation is not reflexive, not symmetric and not transitive. So moving to the next problem. R is a relation defining on the set of integers, and this relation is x minus y is an integer, that is x minus y belongs to the set capital Z. Now if choose the first property, that is reflexive property. Now I'm choosing x minus x, x comma x, then x minus x is 0, which is an integer, that means belongs to Z. That means first property is satisfying. Number 2, x minus y is an integer, since x comma y belongs to this relation. Now if x minus y is a, then y minus x is minus a, which is also an integer, hence number 2 property is satisfying, that is it is symmetric. Number 3, transitive property, x minus a and y minus z. These two elements are integers. Now by the property of integers, if we take their sum, then we'll find x minus z, which is also belongs to the integer. Hence this number 3rd property is also satisfying, that is this is a transitive relation. Here you can check the solution. R is reflexive, R is symmetric and R is transitive. Moving to the next problem. Relation R defining on a set of real numbers where the relation is a less than equal to b squared. So check the first property, reflexive property. I'm taking half comma half. This set does not belongs to this relation R. Why? Since half is always greater than 1/2 square, that is 4. Okay, so this set is does not belong to this relation, that means not reflexive. Number 2, it is symmetric or not. 1 comma 2 is belongs to this relation R, hence 1 is less than 2 square, but 2 comma 1 does not belongs to R, since 2 is greater than 1 square. So number 2 is not satisfying, that is not symmetric. Number 3, transitive property. If I take this two elements 3 comma 2 this set and 2 comma 1.5 this ordered pair. This two ordered pair belongs to the set or the relation R, but you can check 1.5 3 comma 1.5 does not belongs to that. Here it is given. That means not transitive, not symmetric, not reflexive. Next, same type of problem is given as we solved before. Here the relation is A is less than equal to BQ. You can check the solution. Not reflexive. The relation is not reflexive, not symmetric, and not transitive also. So you can solve this problem. Next problem. Here the relation is defining in the set of all books in a library of a college where X and Y have the same number of pages. So number of pages in X book is equal to number of pages in book Y. These two books have same number of pages. Now, if we check the first property, number 1, X comma X, definitely it belongs to R. Since X and X, definitely they have it. Same number of pages are there. So, first property is satisfying. Second property is symmetry property. X comma Y belongs to R, then Y comma X should belongs to R. This property is also satisfying since X and Y have same number of pages. If we interchange their place, that will not disturb this relation. And Y and X is also have same number of pages. Number 3, transitive property. X comma Y belongs to this relation. Y comma Z belongs to this relation. Then X comma Z also belongs to this relation. Since X and Y have same number of pages, Y and Z have same number of pages, then we can say X and Z also have same number of pages. Here you can check the solution. Reflexive, R is symmetric, R is transitive, hence it's a equivalence relation. Next, here I'm considering the set is of points in a plane, and this relation is the distance of these two points from the origin is same. Now here I'm taking this O is origin and I'm taking P and Q, these 2 points in a plane where OP and OQ are equal. That is, this relation is given in this form. So check the first property, P comma P. Definitely it belongs to the relation since OP is always equal to OP. These two distances are always equal. Since first property is satisfying. Number 2 property, that is symmetric property. Here P and Q, this ordered pair belongs to this relation, then OP is equal to OQ. Now if I interchange their position, OQ is equal to OP. Okay, so it will not disturb this relation since symmetric property also satisfying. Number 3, OP is equal to OQ and I am taking another point S here where OQ is equal to OS. Now you can easily check that OP is equal to OQ and OQ is equal to S. That means OP is equal to OS. That means P comma S, need a correction here. P comma S belongs to this relation R. Hence, it's a transitive relation, reflexive also, symmetric also, and transitive also. Hence, it's a equivalence relation. Next problem. Next problem is given. I'm considering the set is L, the set of all lines in XY plane. I'm considering this line like that. Okay, and the relation is given such an ordered pair where P and Q are parallel. So from this picture, you can take this is P and this is Q. Here we can see this P and Q is parallel. Now checking the first point, P, comma P. And we know that each and every straight line is parallel to itself. So symmetry property is satisfying, reflexive property is satisfying. Now check the symmetric property. P and Q are parallel to each other. That is, P is parallel to Q also and Q is parallel to P also. Hence, this reflexive symmetric property is satisfying. Third is transitive property. P is parallel to Q and Q is parallel to S. Here I am taking another straight line S. P is parallel to Q and Q is parallel to S. Then I can easily say that P is parallel to S. That means this transitive property also satisfying. Here you can check R is reflexive, R is symmetric, R is transitive, hence R is equivalence relation. So here is the solution of this previous homework. Here you can check 1, 2, 3 and this 4. Okay, and this second question is very easy. So I think you can solve this question. So I have not given the solution here. So today's homework, these 4 questions are there. Question number 1, question number 2, question number 3 and question number 4. So these questions are very easy. You can solve it. If any problems and any queries are there, you are free to ask. Thank you.